afternoon, and good evening. Welcome to our channel at Steve Gitao 3660. In our today's lesson, we shall look at one of the compounds of nitrogen, and that is nitrogen 1 oxide. For us to study it very well, in terms of its physical and chemical properties, I would like us to have an experiment, a practical experiment, whereby we shall look at the preparation of nitrogen 1 oxide gas in the laboratory. So welcome to the lesson, and I'm your online tutor, Mr. Steve Gitao. First, we look at what are the reagents that we need to use when we are preparing nitrogen 1 oxide. We shall require the chief reagent, ammonium nitrate in solid form. 2, we look at the apparatus. We will require the round bottom flask, this one. We shall also require a delivery tube, a gas jar, or some boiling tubes. We can use a boiling tube to correct the gas, or a gas jar, depending on the test that you want to do. We shall also require a trough for holding our warm water, beehive shelf, and a stand. Viewers, we correct nitrogen 1 oxide gas over warm water simply because it is soluble in cold water, and it is only slightly soluble in warm water, almost insoluble in warm water. But we say it is insoluble or slightly soluble in warm water, but it is highly soluble in cold water. So we shall use here some warm water. And before we look at the reaction, let us straight away go into the preparation. The first step is we add some ammonium nitrate. So here I have some ammonium nitrate. It's white crystalline solid. So we're going to add that into our round bottomed flask. So we add some here, enough for the experiment. Let's add enough quantities. The round bottom flask ensures that we shall be able to spread the heat evenly, and that ensures that our flask does not break. That is enough amount of the ammonium nitrate. The next thing, we ensure that we tightly cork the round bottom flask to ensure that no leakage of the gas goes through. I have some here. We return it to the container. Right. The next thing, since the ammonium nitrate requires to undergo decomposition, we shall heat over the proof frame of a non-luminous frame. So we have our portable burner. Let's do that again. And we are ready for the correction. Now, one thing, as we had hinted earlier, we correct the nitrogen 1 oxide gas over warm water. So I have some warm water here in an electric kettle. Let me add it here. You can see it is steaming hot. Warm water will ensure that our gas does not dissolve in the cold water. There we go. So that is warm water. And now we are ready. We shall let the first few bubbles escape because the nitrogen monoxide gas will be mixed with the air. So let's start heating, and we shall ensure even heating. So a few bubbles coming out, we let it go, we let that escape before we correct. Some bubbles coming out. Let's release more. That is enough. So at that point, we fill our boiling tubes with warm water and we correct. Okay, there we go. We start correcting. We start correcting our gas. We keep on heating. You can see the bubbles are coming. I want to do the heating slowly. Until that jar is full. So we are correcting our nitrogen oxide gas over warm water. Okay, almost full. We are nearing full. One jar, shall see if it is okay, or we can correct another one. Okay, that jar is full, so I will cork it, still underwater. I'll ensure that I correct it. I cork it underwater. Sorry. I will prevent suckback. See some suckback there. So I'll correct that. Put it in my rack there. All right. So we may pause there, and the first thing that I would like us to do is to test the gas. What are some of its properties? You find that the gas is colorless, and you should be able, with the other bottles or the other boiling tubes that we have, correct some more. Possibly, because we still have some left here, let us correct some more. We reconnect so that we do not have suckback. Okay, more is being produced there. That's good. So much faster now, the more you heat. So that is our gas being corrected over water, over warm water. So it's now full. I correct it and I stop it. I can see a case of suckback, so I remove that. Remember, nitrogen oxide is not poisonous, so even if inhaled, it is not poisonous. There is a case of suckback, that's why we need to either to stop or remove this as we continue heating, or we can disconnect at that point. So with my containers here, we can test for the gas using a glowing splint. We're going to use a glowing splint to test for the gas. So once more, I light my portable burner, and then we shall use this one with the wooden splints. So let's test for some of the properties of nitrogen 1 oxide. So we're going to let the splint create a glowing end like that one. So I'm going to open at the top here, put off the frame and insert this one. Wow, so you can see it writes a glowing splint. You can check again, I think it's over there for that container. Let's check another one. I still have a glowing end here. Maybe you can make it bigger. Put it off. So put it off. So let's see. We test this one. Wow, so that is it. We can test another one. It's still active. The third one to see if it's still active. So we go. It's very tight. Quite tight, this one. Okay, so let's see. I hope it has not escaped while we are opening. Create a glowing splint. There we go. You get it there. Perfect. So that enables us to confirm that nitrogen 1 oxide relights a glowing splint. Now let's come to the discussion on some of its properties, on the chemistry behind nitrogen 1 oxide. Number one, the reaction is primarily a decomposition kind of a reaction, whereby ammonium nitrate decomposes. This is decomposition through heat to form nitrogen 1 oxide, and the other product is water. Now, why do we call it nitrogen 1 oxide? This is because the valency of nitrogen is 1, that is, nitrogen valence 1, oxygen valence 2. When we do the closing of these valencies, we obtain nitrogen 2 and oxygen 1. Usually the 1 here is not usually shown. So that formula is for the gas, nitrogen 1 oxide. And we are saying it is prepared in the laboratory through the decomposition, the breakdown using heat of ammonium nitrate to obtain nitrogen 1 oxide and water. Now, we have also hinted that it is corrected over warm water. We used warm water because cold water dissolves the ammonium, the nitrogen 1 oxide. Nitrogen 1 oxide is soluble in cold water, but just slightly soluble, very small percentage of it will dissolve in warm water. The other part is to look at physical properties of nitrogen 1 oxide. Number one, it is colorless. We were able to see that it has no particular color. It is colorless. Part two, it has a pleasant smell. We may not be able to illustrate the pleasant smell, but in an experiment like this one, we are required to waft towards ourselves, our nose. You waft a little and you get a very pleasant smell. That is item number 2. It's got a pleasant smell. Number 3, it causes insensitivity when inhaled. Insensitivity is a situation whereby if there was maybe some pain, the pain goes away. And that's why the use of nitrogen monoxide, which we shall later on see, it was used as an anesthetic. It was formerly used as an anesthetic during surgery in the old days. And patients would be relieved of some percentage pain due to being inhaling the nitrogen monoxide. It causes insensitivity. You do not feel the pain. Number 4, it is slightly less dense than air. That's why when we had the correction, some of the boiling tubes would float on the water. Its density is very, very low. Actually, we are saying less dense than air. It is fairly soluble in cold water, but insoluble in warm water. That one we have talked about. Item number 6 is about the chemical properties of nitrogen monoxide. Number 1, it is an oxidizing agent. It is an oxidizing agent. How is it an oxidizing agent? You find that when nitrogen oxide is passed, this as a gas, we add that, is passed over some heated copper. When this copper is heated, and then you pass this gas over it, you find that the copper becomes oxidized to copper 2 oxide. This is oxidation. The ammonium, the nitrogen oxide becomes reduced. This is reduction. It becomes reduced. So in this case, you find that the donor of oxygen is nitrogen oxide. It oxidizes the copper to copper 2 oxide and itself reduced to nitrogen. So this is an oxidizing agent. Part B, to illustrate the oxidizing property, we have it reacted with sulfur. Sulfur is heated in presence of nitrogen oxide, and a similar scenario happens. The sulfur is oxidized to sulfur 4 oxide. The sulfur gains oxygen, so this is oxidation. Whereas the nitrogen oxide loses oxygen, and this becomes reduction. So this compound here, nitrogen oxide, serves as an oxidizing agent. It donates its oxygen to the sulfur. It donates its oxygen to sulfur. So basically now we are seeing the nitrogen oxide as an oxidizing agent in terms of some of its key chemical properties. Now let's look at what are the uses of nitrogen oxide. Where do we use it in real life? Now, number 1, we have mentioned this one as it being formerly used as an anesthetic during surgery. Number 2, it is used as an oxidizer in racing car engines and rockets. It is used to supply oxygen to those kind of engines, an oxidizer in racing car engines. Number 3, it is used to produce flames in analytical work. Simply because when it burns, it will produce heat, and the remnant nitrogen gas is inert. So it becomes a very good source of heat in analytical work. So in summary now, we are saying that to produce or to prepare nitrogen 1 oxide in the laboratory, we need the chief reagent ammonium nitrate, which when decomposed through heating will generate nitrogen 1 oxide and water. One of the key precautions that we need to take while we are having this experiment is to avoid suckback. And that is why the round bottom flask is placed in a slanted position. And two, when we are ending the experiment, it's always good to continue heating as you withdraw the delivery tube from the water. You disconnect that, and then you can pause the heating. The heating is stopped after you have withdrawn this to avoid cases of suckback. Like in this case, you can find there's some water that is ready to be sucked up. So, and the danger behind that is it may get into the hot flask and cause it to crack. Otherwise, nitrogen 1 oxide is not poisonous, even if it is inhaled. That's why we are not having the gas mask, unlike other oxides of nitrogen, which when we shall prepare, it will be very important to have the gas mask. With that, viewers, we come to the end of our lesson today. Kindly share this video, comment on it, and subscribe on the channel so that we may grow the channel. Let me get your comments on this video, any questions that you like clarification on. With that, I would say thank you for watching.